different rotations that you are going to be responsible for. A rotation of 90 degrees and a rotation of 180 degrees. Okay. So I'm going to write down some rules for these, but I'm also going to show you there's an easier way to look at it than trying to memorize the rules. Okay. The rule for 90 degrees, well, actually first, rotation itself. The rotations occur in the same direction that the quadrants are labeled. And so quadrants are labeled starting in the upper right and then going counterclockwise. And that's how rotations occur as well. So the rotations are always going to happen in a counterclockwise rotation. I tried to say that in a number of these, but even if it doesn't specifically say, it implies or infers that the rotation is always occurring counterclockwise. Okay, so 180 degree rotation is the easiest one. Because if you took an image, so let's take, I'm going to draw an image down here. Let me see if it'll, there we go. All right, so if I took 1, 2, 3, 4, 1, 2. So if I took this point that's 4, the coordinate's 4, 2. Right, if I took this right here, and let me see if I can move it up here. All right, so if I took this image right here and I rotated it 180 degrees, let's take a look at what happens here. So here's my rotation, 90 degrees, a full 180. Okay, when you look at how these new coordinates play out, my new coordinate for this point is -1, 2, 3, -4, down 2. Right? So how does -4, -2 relate to the original point, 4, 2? Yeah, they're exact opposites. So that's the easy one for this. The 180 degrees is going to give you exact opposites. Okay, so let's take a look at what happens with the 90 degrees. Okay, so here's my original. If I rotate this 90 degrees in a counterclockwise rotation, notice what happens to my coordinates. My new coordinate for this rotated point is now -2, +4. So the rotation, the transformation rule that applies here is my new x coordinate is the opposite of my original y, so -y, and my new y coordinate is the original x. Now, trying to remember that rule is probably a waste of time because you can physically sketch your original point like I did right there and then just physically rotate it 90 degrees and then you can count your new coordinates, -2, +4. You don't need to remember a rule for that necessarily, but then once you establish the rule one time, and then you can use that rule to answer the rest of your questions. Okay, so what that means is if I take a look at this problem right here, a rotation of 90 degrees. Okay, so the first thing I'm going to do is if I sketch point T, -2, -9. So let's say that gets sketched right here. So -2, -9. So I'm going to label it. Okay, so if I take this right here and I now rotate it 90 degrees, okay, because I didn't memorize the rule. So once I do this rotation of 90 degrees, I can now see what my new coordinate is. My new x coordinate is what? +9. And my new y coordinate is -2. Once I establish this one time, I can now use this rule. So my -2, my x's become my new y's. So I'm going to take my x of 9, my x of 2, and I'm going to put those into the y's for the translated points. And then what happened to my new x? My new x is the opposite of my old y, right? So I can now take my old y, take its opposite, my old y, take its opposite, and that gives me my points very quickly. Okay? Again, just by testing it one time and physically rotating it and counting the new set of coordinates. Okay, what do you think is going to happen to the area here? Okay, there is no change in area, so it will stay the same. Okay. All right, I want you to answer this next question, which should be pretty straightforward. Like even if you don't remember the rule for the 180-degree rotation, if you do it with 1, rotate it, and then count the coordinates, you'll be able to see what the new rule is and apply that. Okay, but if you do know the rule, it makes it very easy because you're just going to take the opposite of each. So I'm going to go through and I'm going to write the opposite of -4, opposite of 1, or -1, opposite of -7, opposite of -8, opposite of -9, opposite of 1. So there are my solutions. And once again, nothing happens, no change in the area because it's an isometric rotation.